Yes, servers are considered continuous duty for the 80% rule when sizing circuit breakers. The 80% rule dictates that the continuous load on a circuit breaker should not exceed 80% of its rated capacity. The purpose of this rule is to prevent unnecessary tripping of the circuit breaker due to prolonged high current draw. Servers are generally classified as continuous duty loads because they are designed to operate around the clock every day of the week. This constant operation means they place a consistent demand on the circuit breaker even when they are not actively processing heavy workloads. Therefore, when determining the appropriate size of a circuit breaker for a server rack, you must take into account the cumulative continuous load of all the servers within that rack. Doing so will ensure the circuit breaker is adequately sized to manage the anticipated load and avoid unwanted tripping. For example, consider a scenario involving 40 servers housed in a single rack. If each server has a continuous load of 10 amps, then the total continuous load for the rack is 400 amps. To properly size the circuit breaker for this load, apply the 80% rule. This involves selecting a circuit breaker with a rated capacity of at least 500 amps. The calculation is 400 amps divided by 0.8, which equals 500 amps. By adhering to the 80% rule, you can ensure that the circuit breaker is appropriately sized to handle the anticipated load and will not trip unnecessarily. Let's delve deeper into the implications of the 80% rule and its application in server environments. Firstly, understanding the definition of a continuous load is crucial. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. Servers, by their very nature, fit this definition perfectly. Secondly, the National Electrical Code, or NEC, plays a significant role in governing electrical installations, including those in data centers and server rooms. The NEC mandates the 80% rule to safeguard electrical systems and prevent overheating, which could lead to fire hazards or equipment damage. Thirdly, consider the potential consequences of ignoring the 80% rule. Overloading a circuit breaker can cause it to overheat, weaken its internal components, and eventually lead to premature failure. In a data center environment, a tripped circuit breaker can result in downtime, data loss, and financial repercussions. Let's explore the practical steps involved in calculating the appropriate circuit breaker size for a server rack. 1. Determine the continuous current draw of each server. This information can typically be found on the server's nameplate or in its technical specifications. 2. Multiply the continuous current draw of each server by the number of servers in the rack to obtain the total continuous load. 3. Divide the total continuous load by 0.8 to determine the minimum required circuit breaker rating. 4. Select a circuit breaker with a rating equal to or greater than the calculated value. It is always advisable to round up to the next available standard circuit breaker size. Furthermore, it's important to consider other factors that may influence circuit breaker sizing, such as ambient temperature and voltage drop. Higher ambient temperatures can reduce the current carrying capacity of a circuit breaker, while excessive voltage drop can negatively impact server performance. To mitigate these issues, it may be necessary to increase the circuit breaker size or implement other measures, such as improving ventilation or using larger conductors. Let's discuss some common misconceptions about the 80% rule. One misconception is that the 80% rule only applies to circuit breakers. In reality, the rule also applies to other overcurrent protection devices, such as fuses. Another misconception is that the 80% rule is optional. In fact, the rule is a mandatory requirement in most jurisdictions and must be followed to ensure compliance with electrical codes. Let's now consider some examples of how the 80% rule is applied in different server configurations. Example 1. A rack containing 20 servers, each with a continuous load of 8 amps. The total continuous load is 160 amps. Applying the 80% rule, the minimum required circuit breaker rating is 200 amps. Example 2. A rack containing 10 servers, each with a continuous load of 15 amps. The total continuous load is 150 amps. Applying the 80% rule, the minimum required circuit breaker rating is 187.5 amps, which would typically be rounded up to a 200 amp circuit breaker. Example 3, a rack containing 5 servers, each with a continuous load of 25 amps. The total continuous load is 125 amps. Applying the 80% rule, the minimum required circuit breaker rating is 156.25 amps, which would typically be rounded up to a 175 amp circuit breaker if available, or a 200 amp circuit breaker. Let's explore the different types of circuit breakers commonly used in server environments. Firstly, standard thermal magnetic circuit breakers are the most common type. They use a thermal element to trip on overloads and a magnetic element to trip on short circuits. Secondly, electronic trip circuit breakers offer more advanced features, such as adjustable trip settings and monitoring capabilities. Thirdly, high interrupting capacity, or HIC, circuit breakers are designed to handle high fault currents and are often used in critical applications. When selecting a circuit breaker for a server rack, it's essential to consider the available fault current at the installation location. The circuit breaker must have a sufficient interrupting rating to safely clear any potential faults. Neglecting to do so could result in equipment damage or personal injury. Let's now discuss the importance of regular circuit breaker maintenance. Circuit breakers should be inspected periodically to ensure they are functioning properly. This includes checking for signs of overheating, corrosion, or physical damage. Circuit breakers should also be tested regularly to verify their trip settings and response time. In conclusion, correctly sizing circuit breakers for server racks is crucial for ensuring the reliability and safety of data center operations. By adhering to the 80% rule and considering other relevant factors, you can prevent nuisance tripping, minimize downtime, and protect valuable equipment. It's also important to stay informed about the latest electrical codes and standards to ensure compliance and maintain a safe working environment. Remember, electrical work should only be performed by qualified professionals. If you are not comfortable working with electrical systems, consult a licensed electrician. Let's further examine the specific components and configurations within a server rack that contribute to the overall continuous load. 1. Power supplies are a primary source of continuous load. Servers typically have one or more power supplies, each drawing a specific amount of current. 2. Processors consume a significant amount of power, especially during periods of high utilization. 3. Memory modules also contribute to the overall power consumption of the server. 4. Storage devices, such as hard drives and solid-state drives, draw power continuously, even when idle. 5. Networking cards and other peripheral devices also add to the total load. When calculating the total continuous load of a server rack, it's essential to account for all of these components and their respective power requirements. It's also important to consider the efficiency of the power supplies. Inefficient power supplies waste energy, which increases the overall load on the circuit breaker. Therefore, it's advisable to use power supplies with high energy efficiency ratings, such as those certified by the 80+ program. Let's discuss the role of power distribution units, or PDUs, in server racks. PDU are used to distribute power from the circuit breaker to the individual servers in the rack. They typically have multiple outlets and may also include features such as current monitoring and remote control. When selecting a PDU for a server rack, it's important to choose one with a sufficient capacity to handle the total load of the servers. The PDU should also have appropriate overcurrent protection to prevent damage to the servers in case of a fault. It's also important to consider the type of outlets on the PDU. Servers typically use either standard North American or NEMA outlets or international IEC outlets. Ensure that the PDU has the correct type of outlets for the servers being used. Let's now delve into the topic of branch circuits and their relationship to circuit breaker sizing. A branch circuit is the portion of an electrical circuit that extends from the final overcurrent protection device to the outlets or equipment being served. The NEC specifies the maximum allowable load on a branch circuit based on the size of the conductors and the overcurrent protection device. For example, a 20 amp branch circuit using 12 American wire gauge or AUG copper conductors is typically limited to a maximum load of 16 amps, which is 80% of the circuit breaker rating. When designing branch circuits for server racks, it's important to ensure that the load on each circuit does not exceed the maximum allowable limit. This may require using multiple branch circuits to distribute the load. It's also important to consider the voltage drop on the branch circuit. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, use larger conductors or shorten the length of the branch circuit. Let's explore the topic of harmonics and their impact on circuit breaker sizing. Harmonics are distortions in the alternating current, or AC, waveform that can be caused by nonlinear loads, such as servers and other electronic equipment. Harmonics can increase the current flowing through the circuit breaker and can also cause overheating of conductors and transformers. To mitigate the effects of harmonics, it may be necessary to use harmonic filters or to oversize the circuit breaker. It's also important to use equipment that is designed to minimize harmonic generation. Let's now discuss the importance of proper grounding in server environments. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. Proper grounding is essential for safety and for preventing equipment damage. In server environments, it's important to ensure that all equipment is properly grounded, including servers, PDUs, and racks. This can be achieved by using grounding conductors and by bonding all metal parts together. It's also important to test the grounding system regularly to ensure that it is functioning properly. Let's delve into the specifics of the NEC requirements related to overcurrent protection for data processing equipment. The NEC Article 645 addresses the installation requirements for information technology equipment, including servers, in data processing areas. This article provides guidance on topics such as disconnecting means, grounding, and overcurrent protection. The NEC requires that data processing equipment be protected by overcurrent devices that are readily accessible and that have an interrupting rating sufficient for the available fault current. The NEC also specifies that the overcurrent protection devices must be coordinated to minimize the extent of any power outages. This means that the overcurrent devices should be sized and selected to ensure that the smallest possible area is affected by a fault. Let's examine the different types of overcurrent protection devices that are commonly used in data processing environments. Firstly, circuit breakers are the most common type of overcurrent protection device. They are available in a wide range of sizes and interrupting ratings and can be easily reset after a trip. Secondly, fuses are another type of overcurrent protection device. They are typically less expensive than circuit breakers, but they must be replaced after a trip. Thirdly, solid-state circuit breakers are a newer type of overcurrent protection device that offers advanced features such as adjustable trip settings and remote monitoring. When selecting an overcurrent protection device for data processing equipment, it's important to consider the following factors: 1. The available fault current. 2. The interrupting rating of the device. 3. The trip characteristics of the device. 4. The ease of maintenance and replacement. Let's now discuss the importance of arc flash hazard analysis in data centers. Arc flash is a dangerous electrical event that can occur when a short circuit creates a high energy discharge of electricity. Arc flash can cause severe burns, injuries, and even death. In data centers, arc flash hazards can be present in electrical equipment such as switchgear, panel boards, and PDU. To protect workers from arc flash hazards, it's important to conduct an arc flash hazard analysis. This analysis involves calculating the potential arc flash energy levels at various locations in the data center and then implementing appropriate safety measures such as wearing personal protective equipment, or PPE, and establishing safe work practices. Let's explore the topic of power quality and its impact on server performance. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can cause servers to malfunction, experience data loss, and even fail completely. Common power quality problems include voltage sags, voltage swells, and harmonic distortion. To improve power quality in data centers, it's important to use equipment that is designed to minimize power quality disturbances. This includes using uninterruptible power supplies, or UPSs, and harmonic filters. It's also important to monitor power quality regularly to identify and address any potential problems. Let's now discuss the role of uninterruptible power supplies, or UPSs, in server environment. A UPS is a device that provides backup power to servers in the event of a power outage. A UPS can keep servers running for a short period of time, allowing them to be shut down gracefully or to continue operating until the power is restored. UPS are essential for protecting servers from data loss and downtime. When selecting a UPS for a server environment, it's important to consider the following factors: 1. The power capacity of the UPS. 2. The runtime of the UPS. 3. The type of battery used in the UPS. 4. The features and capabilities of the UPS. Let's delve into the topic of generator systems and their application in data centers. A generator system is a backup power source that can provide long-term power to a data center in the event of a prolonged power outage. Generator systems typically consist of a diesel engine, an alternator, and a control system. Generator systems are essential for ensuring business continuity and for protecting critical data and applications. When selecting a generator system for a data center, it's important to consider the following factors: 1. The power capacity of the generator. 2. The fuel consumption of the generator. 3. The reliability of the generator. 4. The maintenance requirements of the generator. Let's examine the different types of cooling systems used in server environment. Cooling systems are essential for removing heat generated by servers and for maintaining a stable operating temperature. Overheating can cause servers to malfunction or fail. Common cooling systems include air conditioning systems, liquid cooling systems, and immersion cooling systems. When selecting a cooling system for a server environment, it's important to consider the following factors: 1. The heat load of the servers. 2. The energy efficiency of the cooling system. 3. The noise level of the cooling system. 4. The maintenance requirements of the cooling system. Finally, let's emphasize the importance of regular inspections and maintenance of electrical systems in data centers. Regular inspections and maintenance can help to identify and address potential problems before they lead to equipment failures or safety hazards. Inspections should be performed by qualified electrical professionals and should include a thorough examination of all electrical equipment, including circuit breakers, wiring, and grounding systems. Maintenance should include cleaning, tightening connections, and testing equipment to ensure that it is functioning properly. By following a proactive maintenance program, data centers can minimize downtime, improve reliability, and ensure a safe working environment.